Sorry, camera just recording was closed. I don't know why, but let's get back on the horse we were riding. So the way of writing n measurement with its uncertainty is measurement of quantity plus uncertain plus minus uncertainty. Remember, it's not plus. We don't know whether it's plus or minus. That's why we write plus minus uncertainty, which gives absolute uncertainty with this one. Least count plus or minus the least count, we will get absolute uncertainty. That's what I told you. For example, length of a cylinder made with a 1 year caliper of least count 0.01 centimeter is 2.35 centimeters. So measurement of the length is 2.35 centimeter, but uncertainty is the 0. Plus minus 0.01 centimeter. Whether we don't know it's 0.001 centimeter above that this measured value or below that measured value. So we write plus minus. So the final length which will be written is 2.35 plus minus 0.01 centimeter. This is the length we made with the 1 year caliper. This is the length of the what we say. This is the length we made. We don't know whether it's plus or minus of this number. So enough with this uncertainty. Let's get back. Let's go to another topic and this is dimension. It is one of the important stuff in their physics because it helps scientists to make new formulas and do a lot of stuffs. So what are the dimensions? The power of base quantities in terms of which quantities may be expressed are called dimension. You might be confused, but let me explain it further, as I had to write some importance of dimensions. I didn't write this article, I don't know why, but we have the advantages and disadvantages of the dimensions. So let's basically we represent base measurements with the letter. For example, let's say for speed we use velocity and it will be v, and for acceleration it is a. We represent these in the base units. For example, we say speed is length over time, because speed is basically distance traveled in time, but as we know that distance is a length which is base unit of the distance, and time is the base unit itself. So speed, the dimension of speed will be L, which is length over time, and you can just write negative power to make it just take it above and negative the power, you will get the dimension, length multiplied by time. Remember to use the first letter of the per base unit. For example, length first letter L and time T, and use the capital version, put in a bracket, and you will get the dimension. For acceleration, we know that acceleration is the change in velocity over the time, so we cannot use change in velocity, but we will write velocity divided by time. We know that velocity is the speed, so we will use this, and the time is negative, which if we multiply with velocity, so we already have -1, and another times come and it becomes -2. Acceleration is lt -2. And a force, we know that force is mass multiplied by acceleration. And what is mass? What is the letter for mass is just m, and we know that acceleration is the lt negative square. So mlt negative square is the unit of dimension. And these are some important dimensions I have listed here. Let's discuss each one by one. And we discuss first what is density. We know that density is a mass acting on a volume. So mass is m. We can state it from here. Mass is m because it's capital, it's first letter for m. And what is the volume? Volume is just length, and length we say that length is the L. So, and it's in the wide form, so we write it in -3. It's because volume is in, for example, centimeter cube or decimeter cubed, and that kind of stuff, and this is in -3. And there here comes the momentum, and we know that momentum is a mass moving with some velocity. So what is momentum? Mass moving with some speed, it causes momentum. So what is the dimension of that? We multiply mass with velocity, and we know speed. Which is speed? lt -1. So mlt -1 is the momentum. mlt negative square is the force, remember. And we can, the rate of change of momentum is change in momentum is also, change in momentum over time is also called force. And last another, here comes kinetic energy. Kinetic energy, we know that kinetic energy is 1/2 mv square. So we know m is just m, and we have velocity, we have speed here, here we have speed here. Take the square of that and put it here, you will get kinetic energy. Here is the frequency. We know that frequency is negative of time, and we will call just negative time. And consult keybook for more. And let's say, I think I copied this from notebook. It should be somewhere. Yes, on the page number 18 of the Scholar publication Physics 11th keybook, you will get these quantities with formula, dimension, SI unit, and in terms of base units. You will get to see units and SI unit name, dimensions, formulas, and quantities. There are more, so consult book for more, basically. And here comes our last but not least topic of this chapter. It is advantages and disadvantages of dimensions. So what dimensions? You know that dimensions have many dimensions are very easy, and it's very important in physics. Advantages, here are the two advantages and two disadvantages. We can check the homogeneity of a physical equation. What is the homogeneity? It is a checking whether the equation is correct or not. For example, if you have I don't get any example. For example, if you want to prove any formula, like equation like Einstein's E is equals to mc square formula, you have to use dimensions to check homogeneity easily. and that's if the both side if the dimensions on both sides are equal, then the equation is stable, means equation is correct. And derived it is also used to derive possible formula for physical problems. Some scientists use it's very easy to use these dimensions to derive some big some formulas, because it directly deals with the base units, and you can easily get a new formulas by uh, having fun with them. So these are the advantages. You can check the homogeneity and you can make some new formulas. But what are the disadvantages? Dimensions do not define angles, as we discussed the plane angle and solid angle. It does not discuss any angles at all, and dimension is not applied for constants. In Yeah, that's true. Dimensions are not applied on constants in angle. That's why these are some disadvantages of dimensions. So here we have done our first what we say unit. We are done with first unit. Congratulations. So it was full of knowledge, I hope so. It was of 19 pages according to the book, but I make some notes out of this to make you able to understand it. So that's it. If you want to check how much you learn, what you learned, you can check it in your book using MCQs and answering to these short questions. I will left this all to you, but try to answer this yourself, not from keybook. If you cannot do it yourself, then learn more until you can do it. Also, do not rely on these questions. You need more than the questions. You need to understand the whole topic. If you understand it clearly, you will be able to answer these questions. These will be piece of cake to it. So try to understand what the topic is, what the chapter is. For example, this chapter was related to measurements. You learned how to measure. You can learn in easily how to measure with the meter rule and these things, and but you've learned about SI units, base units, drive units, supplementary units, dimensions, and uncertainty, error, precision, accuracy, and all those. And some scientific notation, international. Yeah, that's what it was. So review here. I will review this unit using this keybook. Why keybook? Because this keybook gives us what other keybooks do not. That is concept map. I'm tilting my screen to make it clear for you. So at the first, this topic was measurements. It has different sub branches. We said physics, physical quantities, scientific notation, prefixes, conventions of indicating units, errors, which and significant figures, precision and accuracy, and all those. So let's take a look at this first child of the measurement. It is physics. Physics in importance of physics, and you can tell easily by I know you are a student of science. You can easily answer this. It's nonsense. Just they have put a paragraph to describe importance. You can do it yourself. And second is physical quantities, and quantities we made in our daily life, or physical quantities like mass, length, time, etc. And there are two types of quantities. We state one with base units, and other with drive units. We know that base units are 7, and drive units are unlimited because they are drive using base quantities. So that's it. Scientific notations are the powers of 10 to which are used to easily write the numbers. Prefixes are these symbols and letters which are put before any unit, before any monument, to easily to represent some power of 10. For example, nano, -9. For example, uh, mic micro, wait, I don't know, I don't remember, but that's it. If the prefixes are in prefixes are of tens positive powers, it calls multiples. If the negative powers, it calls the submultiples. And let's move on to next conventions of indicating. We indicating for units, that yes, units can be indicated by their measurement. I don't know what this was. It's we did not discuss in this topic, but we can exclude that. Let's move on to the errors. There were two types of errors: systematic error and random error. Random error are those are which can cause by environmental changes, some another you know that it. Systematic is just a wrong use of formulas, methods, and there is significant figures. Significant figures are those which we use, like in scientific notation. We, for example, non-zero numbers are significant, like let's me show, because we haven't discussed this. For example, in quantity like this, these are the significant figures. 1 2 3 4, there are 4 significant figures. Like in quantities like this, we have 5 elements, but we have 3 significant figures. In this, we have these 2, and that's it. These are the significant figures. You can easily understand this. It's a very simple concept. You can easily understand it by looking at the article in the book. So significant figures are done. Precision, accuracy, we already discussed this very deeply, and that how precise, how can we cannot how can we get closer to accuracy and precision. And the last one is dimensions of physical quantities. We said that it is used for checking the homogeneity of physical equations. Means we can check that whether equation is stable, which means equation is correct or not, and it is used to drive new formulas. And that's it. Chapter 1 of measurement is done. I hope it was good time with you. And now the time is 2:54. It took almost 1 hour to complete this chapter. I hope it was worth it. And that's it. See you next time. Take care.